So last video we talked about inverses of relations, and we saw how we could use graphs to determine if the inverse of a function would be a function, right? And we looked at the horizontal line test. Well, now we're looking at finding inverses of a function. So the first thing you could do is to graph the original function to determine if it passes the horizontal line test. Why would we do that? Like, what's the advantage of doing that? The advantage of plotting the original function and seeing if it passes the horizontal line test will tell you if your new function if your inverse function is a function or not. So if your inverse is a function or not, that's why we're going to do this. So that would be the first thing we do. The second thing, we would find the inverse of a function by replacing f of x with y. Then we'll switch our x and y, and then we'll solve it for y. And then finally, we'll replace the y with f inverse x. And we do this to write it in inverse notation. So let's look at example 3. So it wants to find the inverse of f of x equals 1/2 x plus 2 squared, quantities squared. So if I graph that on the graphing calculator, I'll just show it to you here. And I'm just going to draw a sketch. So here's what this graph approximate looks like. It crosses at when this would be -2. This would be at -4. So 1, 2, 3, 4. And something like this would be a good sketch. So I wanted to see if this would pass the horizontal line test, which if we drew a horizontal line through this function, we would see it would not pass the horizontal line test. So my inverse is not going to be a function. I know that because this right here fails the horizontal line test. So my inverse is not going to be a function, but I could still find the inverse. I just know the inverse is not a function. But notice the original thing was, like if I drew the vertical line, it passed. So just because the original function is a function does not mean that the inverse is a function. Notice the inverse would fail the horizontal line test, right? Or sorry, not the inverse. The original function failed the horizontal line test. So let's find what this inverse of this function is. So we're on step 2. So find the inverse of a function by replacing f of x with y. So it says f of x equals 1/2 x plus 2 quantities squared, right? So I'm going to replace f of x with y. So what I'm going to do is write y equals 1/2 x plus 2 whole squared, quantity whole squared. Step 3, switch the x and the y. So I am literally going to switch the x and the y. So this is going to say x equals 1/2 y plus 2 squared. Now we're going to solve this thing for y. So to get rid of that square, I take a square root. And don't forget, when you take a square root, you get the plus or the minus. So this would be plus or minus the square root of x equals 1/2 y plus 2. Solving this for y, I have subtract 2 from both sides. So I'm going to have to work up the page on the other side here. So this will be plus or minus the square root of x minus 2 equals 1/2 y. Now I'm just going to rewrite this as -2 plus or minus the square root of x equals 1/2 y. Just so that my square root's at the end there. Last thing, multiply both sides by 2 to get rid of the fraction there. So these cancel. So this will be -4 plus or minus 2 square root of x equals y. So this is my inverse function. And if I graph, I'm going to put up my graphing calculator here. And I'm going to graph. So I'm going to go y equals, here's my original function. I'm going to graph -4 plus 2 square root of x And then I'm going to graph -4 minus 2 square root of x, all in the same window. And let's change the line type just so we can see the difference here. So here is my original, and here is my inverse. So this bold one is the inverse. Now, if I didn't do the horizontal line test, I could do the vertical line test on the inverse function itself, and I would see that it would fail the vertical line test. So either way, I would see that this is not a function. But you can definitely have the equation. The very last thing we need to do is replace this y with f inverse. So this would say f inverse x equals -4 plus or minus 2 square root of x. So this would be your final answer. This is a nice one to use when you're plugging into your calculator. This one is the answer that I would like to see. F inverse x equals -4 plus or minus the square root of, plus or minus 2 square root of x. Next page. So the next page, what we've seen thus far is that inverses, may or may not be functions of themselves. So if the original thing is a function, you're not guaranteed that the inverse is a function. So you do have to check that by using the graph. If both the function and its inverse are functions, then we call the relation a one-to-one function. So in a one-to-one function, each y value is paired with exactly one x value. So just giving this sort of a name. So y equals x, that would be a one-to-one function because they would both pass the horizontal line test and the vertical line test. So it would pass both tests. So it would be one-to-one. So how do you determine if two functions are inverses of each other? We're going to use what we studied in the last section, the composition of functions. So let's look at this explanation. So if the composition of two functions equal the input value, then the functions are inverses. So what does that say in algebraic terms? That says that if f of g of x is g of f of x, and that is x, then f of x and g of x are inverses functions. So what you're looking for is that these both equal x. And we saw in the notes in the last section that it's not necessarily true that these are the same. So if they are the same, then you know that these are inverse functions. So let's look at an example. Determined by composition whether f of x equals 3x and g of x equals 1/3 x are inverses. So I would take f of g of x, and just like when we did study composition of functions, so first I'm going to take g of x. Well, that's just 1/3 x. We'll plug that result into f. So this is nothing new. This is just like we did in the last section, right? Plugging in, this is our new input. So this output's our input for f. So this is 3. Instead of x, I'm going to write 1/3 x, which that gives me x. So I'm okay there. Now I'm going to check g of f of x. So I know f of x is 3x. So then I'm going to do g of 3x. So just plugging this in here is going to be 1/3 times 3x. So this is equal 1/3 times 3x is just x. So what this says is that here we have f of g of x equals g of f of x, which equals x. So we would say, yes, they are inverses. So let's look at example 5. Determined by composition whether f of x equals 2x plus 4 and g of x equals 1/2 x minus 4 are inverses. So I'm going to do the same thing. First, I'm going to do f of g of x and figure out what that value is. So taking the inside first, g of x equals 1/2 x minus 4. Now I'm going to plug that into my function f. So f, so this is just going to go right here. of 1/2 x minus 4 equals 2 times 1/2 x minus 4. Just plugging this value in for x, just like we did with compositions. So this is 2 times 1/2 x is just x. 2 times -4 is -8 plus 4. This is x minus 4. Already I can see this is x minus 4 and not x. So let's see if this next one will work out just for the practice. So g of f of x we'll do first. F of x is 2x plus 4. So this is going to be g of 2x plus 4 equals 1/2 times 2x plus 4, just plugging this in for x minus 4. So 1/2 of 2x, that's going to be x. 1/2 of 4 is 2 minus 4. So this will be equals x minus 2. So clearly these are not the same. So these are not inverse functions. So these both have to equal x in order for them to be inverse functions. If you don't get that they equal x, then you don't have an inverse function, as in this case above in example 4. So just to make the quick note, because this didn't equal x, as I mentioned earlier, we could have stopped here. Your goal is to have this equals x. If you don't get x, you can automatically just stop. Since this isn't x, there's no way this other one over here is going to be x. So even if this one over here was x, this is x minus 4, so they can't be inverse functions. So that's all for inverse functions. If you have questions, please bring them with you in class tomorrow.